for lesson 10, we're going to go a little bit further into our process of completing the square. So for the opening exercise, we're going to review what we did in our previous lessons. So our first step was we start to wrap those first two in parentheses and we put a line. Then we have our plus one and then minus a line. Remember, you always need two lines. It's always plus with the first one, minus with the second. So now we take our x term, which in this case is the 6. We divide it by 2. 6 divided by 2 is 3. And we square it. 3 squared is 9. And that's the number that goes on both of those lines. Now the reason we put those in parentheses is because we're going to factor it. But if you just remember that the number you get when you divide by 2, in this case positive 3, goes in our parentheses. So we end up with x plus 3 squared. And then on the outside, 1 minus 9 is negative 8. So our x plus 3 squared minus 8. So now here we have a negative 5. So we're still going to start with the same process. So we're plus a line and then plus 8 minus a line. So now we have to be careful here because again, we're going to be, we have an odd number here and we have a negative. So I'm going to choose to keep it as a fraction because like I said, that's how the Regents normally does it. So then we end up with 25 over 4 and 25 over 4. All right, and that's just calculator work. So our factoring goes to x minus 5 over 2 squared because when we divided by 2, we were negative. And then I'm going to use my calculator for this piece for 8 minus 25 over 4. We end up with 7 over 4. So in that case, it would be plus 7 fourths. So those are our basic completing the squares. Now, if you notice in the last completing the square lesson and in these two exercises, it's always a is equal to 1. In other words, it's always just a regular x squared. Now, what happens if we don't have a 1 in front of the x squared or x squared is not by itself? We have to tweak just a couple things here. So the first thing we're going to do is we're going to GCF the first two terms. So between 2x squared and 16x, we're going to take out a 2. So it's going to look like this. And at that same point, we are then going to put in a line. Then we'll be plus 3 and minus a line. So we just have, at the same point as us taking out the GCF, we will add in our lines. So now our process is still the same. We take the middle number, which in this case is the 8, we divide it by 2, and we square it. However, now here's where we have to be careful. That 16 goes on the first line just like normal. The only thing different now is, think about it, this 16 is in the parentheses. What is 2 times 16? Really gives us a 32. So what has to go in the back parenthesis? It has to be minus 32. So inside that parenthesis, we get exactly what we think we should get. But then outside, we have to account for the fact that there is a GCF out in front, and we have to basically like distribute that 2 to the 16. 2 times 16 is 32, so that back line then gets a 32. So we keep our 2 out in front. This parenthesis completes the square the same way. We still get x, and then we had a positive 4, so plus 4 squared. And now 3 minus 32 is negative 29. So now we have a number out in front of our parentheses, and our back line was a little bit different. Other than that, it's still the same process of completing the square. In number 2, complete the square for each of the following expressions. So we're going to do the same thing here that we just did. We have a number in front of x squared, so we're going to GCF just the first two. So we'll take out the 5, x squared plus 4x plus a line plus 23 minus a line. So now we take that 4. 4 divided by 2 is 2, and then 2 squared is 4. So inside that line goes a 4, but then what goes on that back line? Well, what number's out in front? 5. What number did we find? 4. 4 times 5 is 20. So we end up with minus 20 on the outside. 5 goes in front, x plus 2 squared becomes our parenthesis because we had a positive 2 when we divided. And then 23 minus 20 is 3. So now it doesn't seem like we have a number in front of x here, but we do, or in front of x squared. But we really have a negative 1. So we're going to divide those first two terms by negative 1, and we get x squared plus 12x plus a line, and then minus 33 minus a line. So we divide the 12 by 2. 12 divided by 2 is 6. 6 squared is 36. So 36 goes on that first line. Now negative 1 times 36 is negative 36. So we have to be careful. On that back line, it becomes minus negative 36. And now if I were you, I would just be careful with my calculator here, because that's really what you have. You could turn the minus minus into plus, and you end up with a 3. So you have negative 1, x plus 6 squared, and then plus 3. And that's your completing the square for that one when you have a negative out in front. So I want to skip ahead here. I actually want to go to number 4. So write a function that is equivalent to f of x equals 2x squared plus 12x plus 5 by completing the square, and explain how you can check that the functions are equivalent. So we have a GCF out in front, so we have to take it out. So we take out the 2, x squared plus 6x plus a line, plus 5 minus a line. So 6 divided by 2 is 3. 3 squared is 9. So 9 goes on the first line. 2 times 9, which is 18, goes on the second line. So now we've got 2x plus 3 squared. And then on the outside, 5 minus 18 is negative 13. Now, a couple different ways of how we can check to see if these functions are equivalent. We could multiply. So one way would be to multiply the x plus 3 squared in boxes, then distribute the 2 and combine like terms. So that's the long way to do this. The other way to do this would be in your calculator. Y1 is 2x squared plus 12x plus 5. Y2 is 2x plus 3 squared minus 13. And then you want to compare your calculator tables. So really quick, I just want to show you what that looks like here. So we have 2x squared plus 12x plus 5. And then we had 2 parentheses x plus 3 squared minus 13. X plus 3 squared minus 13. So if these two are equivalent expressions, our calculator table should be exactly the same, which you see that they are. So that's all I want to do in lesson 10 on our second half of completing the square.